The Spiti Valley sits more than 14,000 feet above sea level. It is a freezing, barren, high-altitude desert with thin air and hostile terrain. But if you look closely at the loose shale beneath the snow, you find something that defies the environment. These rocks contain the fossilized spiral shells of ammonites, creatures that lived their entire lives underwater. Finding the preserved remains of marine life scattered across the highest, driest mountain peaks on Earth creates a massive physical contradiction. There is no ocean for thousands of miles. To solve the mystery of these fossils, we have to look at the composition of the peaks. The rock layers at the summit of Mount Everest are made of limestone, a substance that only forms at the bottom of a tropical sea. 55 million years ago, this freezing terrain was the Neo-Tethys Sea, a 5,000-kilometer-wide stretch of warm saltwater separating the northern and southern hemispheres. This vast seaway maintained a global greenhouse climate. Its sunlit waters supported a vibrant marine ecosystem, patrolled by apex predators like mosasaurs and filled with billions of shelled ammonites. Looking at these maps at 100 million and 50 million years ago, we see the Indian Plate as an isolated island continent. It broke off from Gondwana and raced northward, closing the ocean gap at 15 centimeters per year. Riding on top of this fast-moving plate was a dense terrestrial ecosystem. The coasts were lined with mangrove swamps and evergreen rainforests packed with ancient palms and arums. The proof of this rainforest survives today in the Valia lignite mines of western India. These small fragments of fossilized tree resin trapped early ants and midges, capturing a biological network of a lost equatorial coast. But this thriving dual ecosystem, a vibrant ocean and a lush island, was on a high-speed collision course toward total tectonic annihilation. Roughly 50 million years ago, India's rapid journey came to an abrupt halt. The leading edge of the plate slammed directly into the massive Eurasian landmass. Usually, a tectonic plate slides into the mantle, but India and Eurasia are lightweight continental crust, so neither could sink. Trapped, the landmasses went straight up, crumpling the rock. The ocean floor, caught in the middle, was scraped off and shoved into an accretionary wedge. This structural stacking progressed through 5 distinct phases of uplift. The process began in the north with the Trans-Himalaya region, and eventually pushed outward to form the lower Shivalik Hills in the south. This mechanical failure to subduct resulted in massive crustal shortening, physically erasing a 5,000-kilometer ocean from the map. The force of this ongoing crash compressed the lithosphere so intensely that it doubled the thickness of the crust here to 75 kilometers. Rising to over 8,800 meters, this massive topographical wall reorganized regional weather patterns, giving birth to the modern Asian monsoon system. The collision is still active. The Indian Plate continues to push northward at about 2 centimeters per year, forcing the mountain range to rise even as erosion tries to pull it down. This explains why the Spiti Valley looks the way it does. Its thin air and frozen peaks are made of the scraped-up remains of a tropical seabed, lifted miles into the sky. The modern Himalayas stretch for 2,900 kilometers, a physical tombstone for a lost ocean, and a coastal rainforest pushed to the edge of the stratosphere.